Hello, my name is Karthik Sisodia and I will describe the producer-consumer problem with semaphores, a multiprocessing synchronization technique. The producer-consumer problem. So before understanding the solution, first let's look at the problem. So that there are two processes. One is producer and another is consumer. They share a fixed size buffer. The producer generates the item and adds the item into the buffer. The consumer, on the other hand, removes the item from the buffer and consumes them. So what happens is there is one producer which produces something, stores in a fixed size buffer, and then comes the consumer which consumes the uh, thing. The challenge here is to ensure the data consistency and avoid race conditions. For example, if producer 1 P1 produces something and stores in the buffer, then only C1 is allowed to remove that item or to consume that item. So if C1 is not found, then there might come a deadlock or a race condition. Or there might happen that C2 might take the object produced by the producer C1. So the challenge is here to ensure the data is consistently flown between producer and consumer through the buffer. So here semaphores help us. Semaphores for synchronization. Semaphore, an integer variable used for process synchronization. So semaphore, as we know, is a integer type of variable which helps us synchronizing the processes. There are two semaphore operations. One is wait and another one is signal. What does wait do? It decrements the semaphore value. If value reaches 0, then the process waits. Signal. It increments the semaphore value from 0. If a waiting process exists, it resumes then. Semaphores for producer consumer. So there are three semaphores for coordination or synchronization between processes. First one is mutex. It is a binary semaphore. What it does, it ensures mutual exclusion when accessing the buffer. For example, if producer P1 is accessing the buffer, then P2, P3, P4 or all other producers are not allowed to access the buffer. Or for example, if after P1, then C1 only allowed to enter the buffer area, not any other C2, C3 or C4. So this is what mutex does. It helps us in mutual exclusion. Second one is empty. It is a counting semaphore. It tracks whether the slots are empty in the buffer or not. Then there comes the full third one. It is also a counting semaphore. It tracks items in the that are currently in the buffer. They are full or not. So empty and buffer are complementary to each other. Now here's a chart we can understand through it. The producer process with semaphores. So producer what does is producer continuously generates the items. It produces them. Then in the wait semaphore, it checks for empty slots. If there are none, then the process waits. If there are empty slots, the process goes ahead. Now to enter the critical section, which is protected by mutex. So that as we discussed in the first or second slide, that mutex allows mutual exclusion. If the process P1 or a producer P1 is taking is executing its critical section, then P2, P3 or any other producer is not allowed to enter the critical section. Now P1 or producer 1 enters the critical section, then it adds item to the buffer. Then there comes the signal that the slot is full and the producer P1 leaves the critical section. Process P1 leaves the critical section and the cycle continues with the further producers producing their object. So this is the producer cycle. Now let's come to consumer's process. What consumer process does with semaphores is it continuously removes the item. For example, if P1 produces an item and stores in the buffer, consumer removes the item from the buffer and consumes them. So it continuously removes the item. Wait. Check for the items in the buffer. If there are none, then wait. The process is blocked to enter the buffer. First, the item has to be in the buffer section. Then only consumer can remove the thing from the stack buffer. Enter critical section. If there is something in the buffer, then the consumer enters the critical section, which is again protected by mutex. Then that means that if consumer 1 is entering the process, consumer 1 is entering the buffer stack, then C2, C3, C4, all other consumers are not allowed to enter it. It removes the item from the buffer. It signals empty, which indicate the empty slot. If this slot is empty, then it signals the producer that you are next, you can come in the buffer stack and enter something there, keep something in the buffer stack. So it leaves the critical section and process the removed item. The item which is removed from the buffer stack, it processes it, the consumer. So this is how consumer process works with semaphores. So in conclusion, semaphores provide a synchronization mechanism for producer-consumer problem. Producer checks the buffer stack is full or not. It produces something and keeps in the buffer, and then it comes out. Consumer checks whether the buffer stack is full or not. If it's full, that it enters, removes the item, comes out of the critical section. The buffer stack is empty again. Now the producer enters the buffer stack and keeps some value there. So this is the process which continues. The semaphores allow or ensure the data consistency and prevents the race conditions. It also enables efficient communication between producer and consumer processes. So this is all about it. Thank you.